Good morning, everyone. Today, let me discuss the concept of distributions in permutations and combinations chapter, which belongs to 11th standard. What is the question? In how many ways can six identical pens be distributed? Identical pens be distributed in two persons. So, suppose if you want to do this problem, we need to go through the combinations. I am going to consider two persons as A comma B. So if I take A comma B are two persons, I can give 0 pens to A and 6 pens can be given to B. 1 pen can be given to A and 5 pens to B. Similarly, 2 pens and here 4, 3 equal pens given to each and 4 pens here and then 2 pens, 5 pens here and here it will be 1 and 6 pens to capital A and 0 pens to B. That means here how many combinations you got? 1, 2, 3, 4, 5, 6, 7 combinations you got in this distribution. Of course, that means the answer for this problem will be 7 as the quantity is very less which we took. That means only 6 identical pens we took here. Hence, it is possible to write each and every combination like this and we can write the answer. Suppose if it has been given like 60 or 70 pens like that, then how you should do this problem? By using one shortcut. The same problem can be done by using one shortcut called C, which is called a scale method. What is that scale method called? You just write down 6 identical pens like this. 2, 3, 4, 5, 6 identical pens like this. By using one scale, you just divide them into two persons. And I'm using one scale. You just keep any scale anywhere you want. This is one scale which I kept. This is called scale. You consider this one as one thing and 6 pens as 6 things. Totally, there will be 1, 2, 3, 4, 5, 6, 7. 7 things can be arranged among themselves in 7 factorial ways divided by, as we are having 6 identical pens, we can arrange them in 6 factorial. Like 7 into 6 factorial upon 6 factorial. 6 factorial will get cancelled. You are going to get circumference. This is the way how to distribute 6 identical pens among two persons. Suppose if I want to distribute these 6 identical pens in for 3 persons, then how to do? So here 6 identical pens can be distributed for 2 persons in 7 ways. For 2 persons means we divided into 2 groups by keeping one scale in between them. Suppose for 3 persons he asked you, then you can arrange like this. Let us write the pens, identical pens, 2, 3, 4, 5, 6 identical pens. You need to distribute for 3 persons, so 2 scales are required. I am going to draw the scales like this. Wherever I want, I can keep like this. This is one scale and this is one scale. So totally 1, 2, 3, 4, 5, 6, 7, 8 things are there. 8 things can be arranged among themselves in 8 factorial ways divided by there are 6 identical pennies. So 6 factorial, which you are going to get it as 8 into 7 into 6 factorial by 6 factorial ways, which is equal to 56. So this is about for 3 persons. Similarly, if you want to distribute these 6 identical games among 4 people, then you should use 3 scales. Similarly, and there will be 9 divide 9 factorial divided by how many similar are there? Alike these are there divided by that much factorial. So the answer for this problem is 56 ways. Thank you. The next question it is, how many rectangles are there in a chessboard? Generally, to count all the rectangles means, see, suppose if we take any chessboard like this, so this entire will become one rectangle, this entire will become one rectangle, and similarly, this entire will become one rectangle. You can't count them by normal places, so you can do by using a small formula like there will be 9 horizontal lines in the chessboard, right? There will be 9 horizontal lines like this. 9 will be there. From these 9, that means 9 horizontal lines will be there in one chessboard. 2 horizontal lines are required to form a rectangle. From 9, 2 horizontal lines can be selected in 9C2 ways, and there will be 1, 2, 3, 4, 5, 6, 7, 8, 9 vertical lines will be there in chessboard, and from 9 vertical lines, 2 vertical lines can be selected in 9C2 ways. Means number of rectangles in a chessboard is given by 9C2 into 9C. The value of, I hope you know how to find out 9C2 value. 9 into 8 by 1 into 2, the value is 36. So 36 into 36 value is equal to 1296. So there will be 1296 rectangles in one chessboard. Thank you. For the next problem, how many squares are there in one chessboard? Generally, we are going to say, if I ask this question, all are going to say 8 into 8 is equals to 64 squares are there in one chessboard. But it is wrong. Why? Because one square becomes one square here, and 4 blocks becomes one square, 9 blocks becomes another square, 16 blocks becomes another square, like that. How many squares will be there in one chessboard? We can't count them, so we can go for like 1 square, 2 square, 3 square, 4 square, up to 8 square. So you can do this one by using one formula for n into n plus 1 into 2n plus 1 by 6. So n is nothing but 8 here. 8 plus 1 is 9. 2n means 16 plus 1 is by 6 is the formula. Now, if you simplify this, you are going to get the answer. 3 is, right? 3 twos, 1s and 2s. You are going to get 204 squares will be there in one chessboard. Let us discuss another question in permutations chapter. Find the sum of numbers formed by the digits 1, 2, 3, 4. What is the meaning of the given question? See, find the sum of all numbers formed by 1, 2, 3, 4. Means, suppose, what is the actual meaning of the given question? Suppose 1, 2, 3, 4 is one number, and 2, 3, 4, 1 is another number, 4, 3, 2, 1 is another number, 2, 3, 1, 4 is also another number. You need to find sum of all these type of numbers formed by those numbers. It becomes very lengthy to do. Then we can do this problem by using two methods. Normal method is, see, let us take these 1, 2, 3, 4 by using the places. Like, suppose the first thing which I am going to do, 1, 2, 3, 4. Suppose 4 is in the units place. You can arrange 4 in only one way, and remaining 3 places can be filled in 3 ways. Then, if 4 is arranged in units place, it can be arranged in only one way. Remaining can be arranged in 3 ways. So 3 into 4, the place value of 4 in units place is 4 itself, so into 1. Similarly, if 4 is in the tens place, this can be arranged in one way. Remaining 3 places can be arranged in 3 factorial ways into the place value of 4 in tens place is 40. So I can write this one as 4 into 10. 1, 2, 3, 4. If 4 is in the hundreds place, then you can arrange this 4 in hundreds place in one way. Remaining can be arranged in 3 factorial ways into 4 into the place value becomes just 400. So it is 4 into 100. If 4 is in the thousands place, you can arrange it in only one way. These 3 places can be arranged in 3 factorial ways into 4 into the place value becomes 1000. So the entire becomes 3 factorial into 4 into, if I add this, you are going to get this function. This is only by taking 4. Similarly, if we take 1 in the units place, 1 in the units place, 1 in tens place, 1 in hundreds place, 1 in thousands place, again you are going to get 3 factorial into 1 into 1, 1, 1, 1. Similarly, if you take that 2 in the units place, tens place, hundreds place, and thousands place, you are going to get 3 factorial into 2, 3 factorial into 2 into 1, 1, 1, 1 again. Similarly, above 3, same you are going to get later. So 3 factorial into 3 into, okay, 1, 1, 1. So if I add these entire 4 quantities, you are going to get the sum. Hence, it becomes a lengthy problem. You can do this problem by using only one shortcut called, see, I am going to do this one with only one shortcut by using n minus 1 factorial into sum of all digits into 1, 1, 1, 1, so on n times. That means what is n? There are 4 digits given to you, so n becomes 4, where n minus 1 is 3 factorial. Sum of all digits means 1 plus 2 plus 3 plus 4 into how many digits are there? 4 are there, so into 1. If I simplify this, I am going to get 3 factorial into, this is 2, okay, 3, 6, 10 into 1, 1, 1, 1. If I multiply this, I am going to get the answer for the problem number 2, right? This is the problem. This is the answer for this problem. The sum of all numbers formed by the digits 1, 2, 3, 4. You should use this time for doing this problem as simple as possible. Thank you.